everyone, this is homework 2.14 and I'm going to go over probably most of the problems from today's homework. And if you need any help, please follow along. I recommend that you try as much as you can do on your own before you watch the video, just to see how much you can do. There will be a code word, so make sure you're listening. Alright, so Andre has a coin jar that contains a total of 85 cents. Alright. There are no quarters or pennies in the jar, so the jar has all nickels or dimes and some of each. We're going to write an equation that relates the number of nickels, dimes, and the amount of money in cents in the coin jar. All right, so first up, important thing here, we have 85 cents. So 85 cents is written as 0.85. So we want to make sure that we write it as that. All right, and then we're going to add up our nickels and our dimes. So in order to do this, you need to know that a nickel is 0.05 cents. Plus our dimes, which are 10 cents. All right, so this tells us and shows us what exactly the equation should look like as it's set up. 0.05 N, it's 5 cents is a nickel, and 0.10 D, 10 cents is a dime. All right, so then it says to graph your equation on the coordinate plane, be sure to label the axes. All right, so in order to graph this, I'm going to go ahead and find my x-intercept and my y-intercept. I'm going to go ahead and say that my n is the x, all right? So let's make this number of dimes, and let's make my x-axis number of nickels. Okay? All right, and so now I can graph these, assuming, again, that my D is standing for the X and my N is standing for, my N is standing for the X and my D is standing for the Y. So let's go ahead and put in, if N is 0, what happens there? So if I make N 0, I get 0.10 D equals 0.85. So calculating that, right, we have 0.85 divided by 10 divided by 0.10 is going to give me 8.5. Okay, we can't have half a dime, so that's a little bit strange, but we're going to go ahead and still graph that as it is. So if we say that N is 0 as our x-axis, then that gives us 1 point that we can plot. So we can say 0, 8.5. I'm going to go ahead and also label my graph. All right, and so we're saying 0, 8.5. All right, that's 1 point. Now I want to find what is my x-intercept. So I'm going to say when D is 0, what does N equal? So that is going to be 0.05. N equals 0.85. And then we're going to divide both sides by 0.05. And we will end up with N equals 17. So if we have no nickels, we would have 17 dimes. So this will be 17, 0. That's another point that I can label. So I probably won't get to 17 here. Let's go ahead and label these in twos. 2, 4, 6, 8, 10, 12, 14, 16, 18. All right, and so this value will be just about there. And so then, again, remember to make sure that you take your straight edge. All right, and I'm actually going to attempt to do this on the tablet. And connect your points so that you're drawing your line there. It should look more or less like that. All right, so how many nickels are in the jar if there are no dimes? So we did that above here, right? In this part right here, this is with nickels and 0 dimes. So there are 17. And then we found that here there would be 8.5 dimes in the jar if there are no nickels. Now, remember that we can't have half a dime, so really there could be no exact option where there are no nickels. There would have to be at least one nickel, so we could have, 8 dimes and 1 nickel, and that would work out. All right, let's go ahead and take a look at these graphs. So, we have Andre. He bought cat food. The next day, he opened it to feed his cat. The graph shows how many ounces were left in the bag on the days after it was bought. So it's asking us to use this graph, how many ounces of food were in the bag 12 days after Andre bought it. So I'm going to go to 12 days, and I'm going to go up to my graph, and I can see that I'm between 32 and 40, right? So I'm going to estimate, right, the difference between that is probably about 36. Well, let's guess, probably about 36 ounces. And then it says how many days does it take for the bag to contain 16 ounces. So I'm going to look at 16 ounces. I'm going to go across and see where it hits my graph, and it's right there at 24 days. How much did the bag weigh before it was opened? So at the very beginning, when we haven't opened it yet, we haven't done anything with it, our starting point is going to be 56 ounces. And then it says how many days did it take for the bag to be empty? So how long did it take to get down to 0 ounces of cat food? It's between 32 and 36. Let's go ahead and we'll say 33, 34, 35. Yeah, that looks like about 33 days. Okay? All right. Let's try our Little League baseball team. The Little League baseball team is ordering hats. The graph shows the relationship between the total cost in dollars and the number of hats ordered. So this makes sense. As we order hats, right, the more hats we order, the more it's going to cost us. So what does the slope of the graph tell us in this situation? All right, so remember, first of all, slope is your rise over your run. It's how much you're going up over how much we're going across. So the best way to do this is to kind of find two perfect points and to look at the distance between them in rise and run. So our rise here, right, this part right here, is going from 120 to 160. So that's a rise of 40. So we have a rise of 40. And then our run going across, right, from here to here, is going from 6 to 9. So that's an increase of 3. So let's just double check, 1, 2, 3. So our rise over run is 40 over 3, which means our slope is 40 over 3. We can go ahead and calculate that, put that in a decimal, because it'll give us more information, which is 13 1/3 or 13.33. And it tells us, so now we want to see, like, what is this telling us? Is it telling us there's a fixed cost of approximately $35 for ordering hats? That is what our y-intercept is telling us. That's not what our slope is telling us. We do see that right, probably about there, we're starting at $35. So that means, like, no matter how many hats we order, we're going to start with a fixed amount of $35. That's our y-intercept. It tells us that that the total cost increases for each additional hat ordered. Okay, so is that saying that every time we order another hat, it's another $13.33? This seems like perhaps a good option. Let's try C. It tells us that when 9 hats are ordered, the total cost is approximately $160. Well, it is true that when 9 hats are ordered, we have a cost of about $160, but that's not what our slope is, right? That's a point. Again, not really our slope. Letter D tells us that when the number of hats ordered increases by 10, the total cost increases by approximately $175. So let's see. If we increase our hats, right, by 10, we go from 0 to 10, then it says we have an increase of approximately 175. Yep, that is also true. But that is not telling us, that's not what our slope is telling us. So our slope is going to be B. It tells us the amount that the total cost increases for each additional hat ordered, right? That slope is your unit rate, okay? 40 over 3, when we divide that, it tells us how much additional per hat that is ordered. All right, let's try number 4. A group of hikers is progressing steadily along an uphill trail. The graph shows their elevation or height above sea level. That's what elevation means, height above sea level. In feet at each distance from the start of the trail, in miles. Oh, okay, so we have feet and miles going on here. All right, so it says, what is the slope of the graph? Show your reasoning. So again, we are going to look at our rise over run. I like to pick a nice even point. So here and here, we notice there's like some nice intervals at all of these points, right? So we're looking at this right here. All right, so our rise is, first of all, our slope is positive, right, because it's increasing. So our rise is, it's going up 500 feet. And even though it looks like 1, we have to pay attention to these units on the side. So it's going up 500 feet, that's our rise. Over our run is 2 miles. All right, so 500 feet per 2 miles. So for every 2 miles that I travel, right, I'm increasing my elevation 500 feet. If we want to reduce this a little bit to make it to 1 mile, we can say for every 1 mile, I'm increasing my elevation for 250 feet. So it says, what is the slope of the graph? Show your reasoning. So we have 250 feet of elevation per 1 mile along the trail. Okay? What does the slope tell us about this situation? So again, it tells us for every mile, for every 1 mile, we increase elevation by 250 feet. Letter C says, write an equation that represents the relationship between the hiker's distance from the start of the trail, x, and their elevation, y. All right, so to do that, we're going to say y equals, it's our elevation here, y equals, and then our slope, which is 250 feet per mile, right? That's important to say. So 250, for simplicity, will 250x. And then we're starting at an elevation of 500. That's our y-intercept. Okay, so now we have an equation from the hiker's distance from the start of the trail and their elevation. So when they start at the trail, they're already at 500 feet elevation. And for every mile that they go, if I put that in for x, every mile that they go, they're going to increase their elevation by 250. All right, it says, does the equation y minus 250x equal 500 represent the same relationship between the distance from your start of the trail and elevation? So that's asking if we move this equation around, right, are they equal? So let's see, what steps would we need to take to get to that? All right, well, if I wanted to move this 250x to the other side, I would in fact subtract from both sides. So that would then give me y minus 250x equals 500. And so yes, they are equivalent, and so they do represent the same relationship. So, and if we were to plug in numbers, we would get the same solutions. And so we know that because we have the same solutions, we would have the same solutions for these, that these equations must be equivalent. So yes, same solutions, and we can get to this equation by subtracting $250x from both sides. So remember, we always have to do it to both sides. All right, so that's it for your homework tonight. Ooh, I have to sneeze. Ooh. Excuse me. All right, so your code word today is sneeze. Let's just go ahead and go with that. Your code word today is sneeze. Hope that gave you a little laugh. Write it on your paper if you'd like extra credit. Let me know if you have any questions, and have a great night.